Hey Math B. So what your homework is right now is I need you guys to take out lesson, what are we looking at, 2.1c, and we are going to finish it. I think most of us got up to number 3. Now as a reminder, we were looking at the difference between proportional and non-proportional relationships. We did several things by looking at the graphs. This was proportional. This was non-proportional. We also looked at tables. If it had a constant of proportionality, that's when we looked at y over x, and if all the values were equal, it was proportional. And when we looked at all the values of y over x were not equal, it was not proportional. And what we're going to do now is see if it has something called for a constant first difference. So let's go ahead and read this really quickly. It says, a constant first difference in a table of values is the difference of y values for your consecutive x values. All linear relationships have a constant first difference. Now, good news. If it has a constant first difference, it also has a constant rate of change. You guys already looked at and figured out how to find constant rate of change. That's the rise over run, or how much your y value changes over how much your x value changes. This is very similar now. It says, state the constant first difference of each table. Now this is talking about the table of Oliver and Sarah. So I'm going to redraw these. We had x and y, and Oliver's table looked something like this. So it was 0, 2, 4, 6, 8, something like this. Now what a constant first difference is, we're going to look at this definition. In a table values is the difference. Remember, difference is answers to a subtraction problem. In y values for consecutive x values. So, a constant first difference is, in order to determine if something is linear, you can look at tables. If tables give you consecutive x values, so in this case it's 0, 1, 2, 3, 4. These are all consecutive integers. All you need to do is subtract your y values. This is 2 minus 0 is 2. 4 minus 2 is 2. 6 minus 4 is 2. And obviously 8 minus 6 is also 2. This is what a constant first difference is. All you need to do is look to make sure your y values are equal. Excuse me, totally misspoke that. All you need to do is make sure you have consecutive x values. 0, 1, 2, 3, 4, which I do. And all you need to do is subtract your y values from each other to see if all those values are equal. If this is true, which it is, we can say that the relationship is linear. So the relationship is linear. So, state the constant first difference for each table. Well, the first one was 2. Let's see what the second one was now. So the second table, that was Sarah. Sarah's boss was a little nicer. She got $8 for just showing up to work. She didn't need to sell any bag of popcorn. Let me flip these around because they're wrong. So, for doing 0 hours of work, Sarah got $8. One bag of popcorn was $10. 2 bags of popcorn was 12. 3 was 14. Now remember, the first difference, you see if you have consecutive x values. 0 to 1, 1 to 2, 2 to 3. I do. So all you need to do now is subtract these. All the values are the same. This is linear. So 10 minus 8 is 2. 12 minus 10 is 2. 14 minus 12 is 2. This is a constant first difference. Therefore, it is linear. So the first difference is all 2, so it is linear. So it is also 2. How does the constant first difference relate to the rate of change? And what it is they are the same. how does the constant first difference relate to constant of proportionality? Now this is important. A constant of proportionality and a constant first difference are equal when it is proportional. So they are the same when you have a proportional relationship. Awesome. Alright, so now if we graph each situation on the coordinate plane, we're going to label our axis. So the first one is popcorn sold. And the next one was basically the money they got. So I'm going to have Oliver in purple. He sells 0, he gets 0. He sells 1, he gets $2. 2, he gets $4. 3, he gets $6. 4, he gets $8. So on and so forth. And now hopefully you guys notice his stairs. Remember the staircase? We're not going to connect them because this is a discrete graph. Because I can't sell half a bag of popcorn. But I go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Remember, his rate of change is the same as slope. It's the staircase. It's the same as the rise over run. Now, if we remember Miss Sarah's boss, she's a little nicer. She gets $8 for showing up. And then she gets 2 bags of popcorn, $2 per bag of popcorn as well. Same idea. She has the same slope. Up 2 over 1, up 2 over 1, up 2 over 1. So when it says label your graphs, we just color code these. We could say orange is Sarah. And we'll say purple is Oliver. Should the graphs be discrete or continuous? Now we would say discrete. So they are discrete because you can't sell half a bag of popcorn. Which person earns more money for every bag of popcorn sold? Now, it's very important. It's not asking who made more money total. It's asking who makes more money for one bag of popcorn they sell. They both get $2 $2 for every one bag of popcorn. Therefore, they are the same. So they are the same because they both get $2 for one bag of popcorn. Alright, write in an equation that represents Oliver's situation. So we're going to be introduced to writing equations. We kind of looked at this at the lesson with geometric figures. I want to write in words what it represents before I actually build it. So Oliver's total money is equal to the rate of change times the independent variable. So let's go ahead and look at this now. The total amount of money is going to be Y, is equal to his rate of change, his rise over run, how much money he gets per bag of popcorn, which was $2. And we almost always write X for independent variable. This is his equation. So now let's go ahead and look at Sarah's. Sarah's was different. The amount of money she gets is her rate of change plus her start value. How much she gets for showing up for work. So let's go ahead and look at hers. Her total amount of money is $2 for every bag of popcorn plus the $8 just for showing up. I want you guys to notice they have the same rate of change. It's both $2 for every one bag of popcorn. But Sarah has a plus 8. That plus 8 represents the $8 just for showing up to work. Examine your equation for each situation. What conclusion can you make about non-proportional relationships? So, when we look at our equations, non-proportional relationships they will have a plus or a minus in the equation. So an example of non-proportional will be y equals 2x plus 4. That plus 4 makes it non-proportional. Y equals 1/2 x minus 3. This minus 3 is what makes it non-proportional. If I had an equation like y equals 5x, this is proportional. Or if I have the equation y equals negative 2/3 x, that is proportional because it doesn't have a plus or a minus. It has a negative, but not a plus or a minus. Alright, Sunset Waves charges an entrance fee of $5, then charges $2 per hour. Paradise Pool just charges $3 per hour. So let's go and look at this. So what I would like you guys to do, I'm actually going to pause the video here, and this number 3 will be found in the next one. So you can try number 5 and then look at the next video to correct your answers. Or if you still need a little bit more assistance, go ahead and stop this video and start the next one. But regardless, I want you guys watching the next video, okay?